Okay, so the next thing that we want to do is find the sample variance and standard deviation of a data set. And I need to give you the formula, and then we're going to look at it with the data set. So the first off is the sample variance and standard deviation initially look a lot like the population standard deviation and variance. So sample variance is given as s squared, and it's equal to the sum of the difference between the data points and the sample mean squared divided by, and here's another difference, the number of data minus 1. You have to take 1 off of that data. So x is the data, x bar is the sample mean, and n is the sample size. Okay. And then standard deviation would be just the square root of that. S is the square root of that formula. Okay. Now, the problem is that although this looks nice, and the next formula that I'm going to use doesn't look as nice, it turns out that it's a much easier formula to use when calculating the samples, variance, and standard deviation. So the formula used to calculate s squared and s is this one. It looks a little more complicated, but it's actually easier to gather the data for. So it's the sample size times the sum of the x squareds minus the sum of the x's, that quantity squared, divided by n times n minus 1. Okay. And then, of course, s is just the square root of that same formula. So n times the sum of the x squareds minus the sum of the x's squared over n times n minus 1. All right, so those are our formulas. This one is just easier in the long run to use. So let's do an example, and we'll set up our data and our data table for all this stuff that we have to do. Okay, so we want to find the sample variance and standard deviation. And while we're at it, let's find the range. Okay, so this is about hardcover books that are on the bestsellers list. The number of weeks they're on the bestsellers list on the New York Times. So hardcover bestsellers. So number of weeks on the New York Times bestseller list. And this is just a sample. So we have 1, 4, 2, 2, 3, 18, 5, 5, 10, 4, 3, 6, and then 2, 2, 2. Okay, so what we have to do is create a table. So we kind of did that before on the other one, but this one's going to have a few more things on it. So we need a table where we have our x values that we want. Okay, and then we need our x squared values, because if we look at this formula that we're going to use, we need to be able to add up our x values, and we need to be able to add up our x squared values. So let's go list these data points. So I'm going to list them. Am I going to list them in order? You don't have to list them in any order because we're not finding the mean, median, mode, all that kind of stuff. But I'm going to list them in order just for the sake of it. So here's 1, there's 1, 2, 1, 2, 3, 4 more, 1, 2, 3, 4, then 3 twice, and then 4, 1, 2 times, and then 5 twice, 6 once, 10 once, and 18 once. I wonder what that 18 was. All right, now we got to square each of these numbers. So 1 squared is 1, 2 squared is 4, 4, 4, 4. 3 squared is 9, 4 squared is 16, 25 for 5, 36, 100, and I haven't a clue, I'm going to figure it out. 18 squared is 324. Okay, now that I have this table, I need to actually add up both columns. Okay. Separately, of course. So 1 plus 2 times. Okay, I get 71 here, and then and 585 here. All right, so now I have all the numbers I need. This thing down here, the 71, is the sum of the x's, and the 585 is the sum of the x squared. So let's go look at our formula that we're plugging this information into. I'm going to go grab that formula. So let me get rid of some of these parts. Okay. All right, so now we're grabbing this formula for variance. I'm going to bring it down here so we can look at it while we're doing it. Okay, so our variance, if we look over here, our n is the number of data points. So how many data points do we have? 1, 2, 16 data points. Okay, and our sum of our x is 71, and our sum of our x squared is 585. All right, so now we're going to plug that information into this formula. So n is 16 times the sum of the x squareds, 585, minus the sum of the x's squared, so 71, and I got to square that. And then the whole thing is divided by 16 times 16 minus 1. So let's simplify this. So 16 times 585 is 9360 minus 71 squared, which is 5041 over 16 times 15. All right, so now we keep going on and we simplify this expression. So the difference in the top is 4319 over 240. So 4319 divided by 240 is 17.996. So once I get that answer, that's my variance, that's my sample variance. And then to find my sample standard deviation, we take the square root of that answer. So that's S equal the square root of that 17.996. And we get 4.24 as my sample standard deviation. Okay, so to do this with these populations or these samples, you have to create these tables of values. And notice we didn't really have that much to create with this formula that we're using right here. There wasn't that much data we had to create to do this. If I tried to use the first formula, the first thing I'd have to do is find the average, then find the difference between the data points and the average. So I'd first have to find the average, then I have to find this difference, then I would have to square it, and then I divide by n minus 1. That would cause me to make like 3 or 4 different columns. But with this formula, we only have to have 2 columns. That's why it's easier formula to use. Okay? All right, so that's that. The next thing that we want to do, and we're going to find the range. Sorry, let's find the range. So the range, remember, is just the highest value, which is 18, minus the lowest value, which is 1. So this has a range of 17. All right, so the next thing that we have to do is find variance and standard deviation for grouped data. And then we have other stuff after that. So it just keeps going. I'll take another video.